This video presents a robust and compliant controller for cooperative multi-robot manipulation. Compared to a single robot, using multiple manipulators enables higher dexterity and the ability to handle large, flexible objects. However, disturbances or modeling inaccuracies can cause tracking errors, leading to task failure or large internal forces damaging the object or the robots. We propose a distributed controller that combines the compliance of impedance control with the robustness of super twisting sliding mode control. In the first task, the robots manipulate an object along a trajectory that includes several rotations and translations. We compare the proposed controller to standard impedance control and sliding mode controller baseline. Simulation results with significant joint friction disturbance show that both sliding mode controllers significantly improve both translational and rotational tracking accuracy compared to the standard impedance controller. In the second task, we apply external disturbances, both forces and torques, to the object. Simulation results show that combining impedance control into the sliding mode controller helps to reduce the internal object forces compared to the sliding mode controller baseline, improving the safety of the system. In the third task, we demonstrate the advantage of our distributed controller design. The robots are moved to a different configuration and only the grasp points are updated in the system. No other changes to the controller are required. Finally, the controller is validated on hardware using two 7-degree of freedom Franca-Amica manipulators. The system runs with the same parameters as in simulation and uses estimated end effector wrenches from the joint torque sensors. Future work will include incorporating human-robot collaboration and designing variable impedance parameters. Thank you to the IES SYP Activity Committee.